So let's say we have a language. We're not going to worry about the empty string. We're just going to leave that to the side. A context-free grammar is in what's called Chomsky normal form. If all of the productions look like this, they're either a variable being replaced by two variables or a variable being replaced by a terminal. Okay, so if the grammar can be, if the grammar is written in this way, this is Chomsky normal form. So what does that mean? At each point, and we might have multiple productions. We might have A being BC or being something else, DE or A, and then B, C, and D, whatever, these being something else. So we might have multiple productions in this form, but every production is one variable being replaced by two variables or a variable being replaced by a terminal, and it might be multiple terminals as well, right? So lots of possibilities. And so the idea here is that this particular format, this particular form, we're going to use it primarily for, this has particular proof purposes that we're going to use it for. We're going to look at another form in a little bit that is really useful for calculations. All right, so let's suppose that we have some grammar The terminals are A, B, and C. And this is the grammar that we have for whatever language. We can figure out what language this is. Actually, let's try to figure out what language this is. Let's see if you can tell what the language is for this grammar. All right, we'll come back to it, right? Experimentation, trying some strings to see what kinds of strings are here, what can you generate, what can you not generate. We'll come back to it and see what the language looks like. Okay, so to convert this to Chomsky normal form, what do we have? We see lots of things wrong with this particular grammar as far as fitting those requirements. What happens right here? There's too many pieces. Right? In the S, there's mixture of terminals and variables. That's not good. Here, these are terminals and variables mixed. That's not good. This is not a terminal. We have to get rid of that. This is too short. There's only one variable. That's okay. We have one thing that's okay. One production rule. Y can be replaced with the terminal C. Other than that, we have a lot of changes to do. So the first thing that we want to do to convert is we want to eliminate all the lambda productions. In this case, there's only one. So we need to eliminate this production. How can we go about eliminating this lambda production? Well, the lambda production would come into play if we turned y into x and then x into lambda. All right, so what does that mean? That means that x being transitioned to ay, if the y gets transitioned to x and the x gets transitioned to lambda, what do we need to do? We need to replace that production. I'm going to replace the whole line because we have it written in this way, but we need to replace this production with the end result of x going to ay, y going to x, x going to lambda. And then we need to replace also with the possibility of x going to by, y going to x, and x going to lambda. All right, so what happens? X can still transition to ay or by, but instead of lambda, let's follow this path, and x could also be replaced with a or b. Okay, so what happens is our lambda production is going to be replaced with what would happen if we ever used that lambda production. If we ever used that lambda production, one output would have been A, the other possibility would have been B. All right, so we can't have any lambda productions because the form doesn't allow for it. So we eliminate the lambda productions. What else do we need to do? We need to get rid of a production like this. Y transitioning to the variable x, because that's a unit production, right? So we need to eliminate variable unit productions. All right, so what does that mean? Instead of y becoming x, what does y need to become? Y needs to become all the things that x could become and whatever else y could have become. All right, so rather than x, we're going to say, okay, well, y can become all the things that x could be replaced with and anything else that y already could be replaced with. Okay, so we've eliminated that unit variable, right? Just y going to a single. But now we still have these issues that don't fit the rules, and we have this thing that's too long. Okay?
Is Chomsky normal form? Like, I'm not sure if it's in my notes.
That's what it is.
Right.
That's the definition. We just defined it.
Oh,
right?
I
So
thought it was like something old or something.
no, this isn't something old. This is just something that we're defining right now. This is a form for a context-free grammar that looks like this. Okay, so now what do we need to do? We need to eliminate long productions, right? The productions that have too many pieces. And then we will need to fourth step, move all terminals to unit productions. Okay, so let's think about what's going to happen here. We're going to kind of do these two in one step. We need to be able to break AX, BX up into things that just involve two variables. So what might we do? We might say, okay, this part and this part can become variables. AX, BX could become E. E could become a new variable like this, AX. F maybe becomes a new variable like this. And so what happens to this production? This production becomes this production, right? EF. Does that make sense? All right.
The idea is that so what's the idea behind this? Like, what's the purpose of?
Well, like I said, we're gonna use it in a few minutes, but we're trying to convert something to this form. What's the idea that we have is that instead of having big, long, messy transitions, maybe like where we have multiple pieces, we have exactly two things that something will transition to. All right. So what idea do we have here? We're trying to get something into a particular format so that we will have what kinds of derivation trees? What would a derivation tree look like? When you replace a variable, what do you replace it with?
Only one or two.
Either two variables or a terminal. Right? So what's going to happen to our derivation trees? What will they look like?
Not exploding.
Not exploding, they'll be binary, right? Because every time you replace a variable, you can only replace it with two pieces. And so the derivation trees will be nicer in that aspect. Now what happens though to a derivation tree if you can only do binary replacements? What will happen to the trees? They'll become much longer potentially. Right? So the trees might become much longer, but at each step there's less to focus on, right? Each thing is replaced with two other variables or a terminal, which will then terminate that branch. Okay, so what happens here? We wanted to eliminate the long productions, but we also need to move all the terminals to unit production. So we can't have things like this anymore. All right, so what's going to happen here? Let's rewrite what our grammar might look like right now. This situation, E becoming AX, F becoming BX, this will resolve some of what can happen. So BX. We need to make sure that we've covered every possibility, that we have everything that we might want to take care of. So there's still some possibilities here with eliminating this long production. But let's see what it looks like to get rid of these terminals. How do we get rid of these terminals? Well, not those, right? Those are actually terminals by themselves. How do we get rid of things that have a terminal and a variable involved? We could create new variables. A, B, and C. And then do what? Replace this with A. Replace that with B. Replace that with A. Replace that with B. Replace that with A. Replace that with B. All right, so we're getting closer. We have all of these pieces now. All of these productions. All of these down here look correct. All of these fit into that mode. The only question is, did we really cover all the possibilities from up here? So in terms of the long productions, the long transitions. So we want to be careful and make sure that we really did create everything that we wanted to create. We have to remember back here that what happens with the X? The X, we can eliminate entirely. And so what happens, we're going to need to include some other possibilities back here, not just EF, because you might have just the E with a B after it, because the X was able to be eliminated. Does that make sense? And so what happens is we might be able to create E with just a single character B, and to do that would look like this. We might be able to produce the character A with then F after it. So that's a possibility. And we also might be able to create just the A and the B characters by themselves. So this is a possibility. All right, now we weren't very careful in how we went about doing that, but remembering that X could be eliminated entirely in the earlier, because it had the lambda transition, we have this eliminating this long production requires 4 productions in its place, right? 4 potential pieces. All right, now again, maybe we can optimize this and we can reduce things. But what happens? There we go. Our original grammar just got a lot longer. So a lot more productions and a lot more pieces. But what happens to our grammar? Our grammar now has a nicer format in the sense that the derivation tree is a binary tree. Okay, so here's what happens in terms of, well, before we do this, let's try an example. Let's let you try an example. A smaller grammar. Let's say S